Today we are going to look at a new circuit. It's an audio oscillator circuit. It it produces oscillation at the audio frequency range. We have already looked into the transistor circuit, where it can be used as a switch, and it it also was used as an amplifier, as an audio amplifier. And now we are going to look at a circuit where the transistor can be used as a oscillator. It can produce different types of oscillations. It produces oscillations such as the sine wave, the triangular wave, sawtooth wave, and square wave pattern. There are different types of oscillations that are produced by by a transistor oscillator. So this is what we are seeing is an audio oscillator. It produces oscillations in the audio frequency range. And here we have two transistors. We have two transistors that are connected directly close. It's a DC coupled. It's a directly connected transistor. It's a PNP. It's a PNP transistor here, and there is an NPN transistor also here. And it is the base of one transistor is directly connected to the collector of the other transistor. And there is also a feedback network that is connected from the base of from the collector of the PNP transistor, which is carried through a resistor here, like an RC loop. One resistor and one capacitor here. This is the looping capacitor. This is the resistor, which has a series connection. It connects the base of one of the transistors and to the collector of the second transistor. So that way the output is coupled to the input of the amplifier, the transistor amplifier stage. So it is it forms a feedback network. It's a positive feedback network, and that produces it's an RC coupled positive feedback network that produces audio oscillations. It's not a radio frequency. It produces very low frequency audio oscillations. So that is what this circuit is. And here also we have given a potentiometer that can change the frequency of oscillation, audio oscillations. So we can adjust this potentiometer to change the frequency. And the collector is the output of the collector is directly connected through a 8 ohm speaker. It's an 8 ohm speaker. It's connected through the collector and to the ground. So this is the simple circuit. So I'll just connect the switch on the oscillator. So this is how it is. So we can adjust the frequency. This is the lowest frequency of oscillation. It has considerable sound. So we can adjust the speed like So this is how it is working. You can adjust the speed. So this is how it is working. So this is the frequency determining capacitor. It's the frequency. The frequencies it's determined by this capacitor and this resistor. So we'll just change the uh, capacitor here and place another capacitor, and we'll just connect it. This, you can see the sound. So this way we can adjust the frequency of oscillation. And just change this to another capacitor. So the frequency of oscillation has come down very. It has very is oscillating very slowly. So this is like 1 hertz. It's the maximum frequency. So this is the when you increase the value of the capacitor, the frequency of oscillation will considerably decrease. So when you it all depends on the the capacitance value of the capacitance that we are putting here. When you put a very high value low value capacitor, the oscillator it oscillates very fast. It oscillates in the higher audio frequency range. When you put a higher value capacitor, the oscillation the frequency of oscillation reduce to a very low value. So that is how the relation between the capacitor and the oscillator. You can similarly change this resistor also considerably. It can slightly adjust the frequency, and also this control we can also still we can make changes in the frequency of oscillation. So these are the things that we can study from a simple audio oscillator, a very simple circuit that we can build it. Okay, so thank you.